Alright, this topic is graph features of polynomial functions part 2. And so this is the second part of graph features of polynomial functions, and in this part there's going to be 3 objectives. I'm going to break this up into 2 videos, and in this video I'm going to go through objective 1 and 2, and then in the next video I'll go through objective 3. So, objective 1, and again this is all based off of if you're given a graph of a polynomial you should be able to do the following objectives to continue on. And the first one is to determine the intercepts with multiplicity. So if given a graph of a polynomial function, you should be able to determine the intercepts with multiplicity. So a goal to consider when working through that is to recognize x-intercepts and what even or odd multiplicity makes the graph do at that x-intercept. Or, if looking at it, what happens, is it going to be an even power or odd power if it bounces and goes back in the same direction or goes through at a certain intercept. And then objective 2 is write the polynomial function in factored form based off of the x-intercepts with multiplicity you found in objective 1. So the goals there are to understand the relationship between the x-intercept, and I put root to 0 because it's the same thing, and the factored form of that x-intercept. That's really key, and we're going to talk about that. And then understand the relationship between the multiplicity you found in objective 1, sorry, that should be objective 1, and then the power you use for each factor when you write it in factored form. Before I show an example of this, I have to talk through some key terms, or I guess in greater detail. And so let's go through that. Part A, intercepts with multiplicity. In multiplicity, all I mean, or all it means when you say that, is how many times the solution exists. Solution exists. And it's written something like x equals 2 with the multiplicity of 2. All that means, this little m denotes multiplicity, and what that little m means is that that solution, x equals 2, shows up twice. So instead of writing x equals 2 comma 2, you just write x equals 2 multiplicity 2. And let's move on to, here I'll draw a little separator box. Even versus odd multiplicity, alright? If it's an even multiplicity, so let's say x equals 3 multiplicity 2. That's going to, at that 0, it's going to, or at that solution x equals 3 on the x-intercept, it's going to come down towards 3 and bounce off and go back in the same direction it started from. And we'll talk about that when we look at the graph. But just keep that in mind, even multiplicity bounces, or that solution bounces off the x-axis. Versus odd multiplicity, so x equals negative 4 multiplicity 1. So at negative 4 on the x-axis, it would go through the x-axis. It wouldn't bounce off, it would go through. And so that's something to keep in mind when you're actually looking at a graph. You should be able to say, oh, the graph goes through at x equals negative 4 through the x-axis, so I know its multiplicity has to be 1. Now, let's move down to factors versus roots. This is another goal that is really huge and really key for this skill, and these couple skills. We've worked through this process of factored form versus root form, especially in Module 3, and so I'm going to show you what I mean by this, and technically, any factor has a root, and any root can be written in factored form. And so I came up with this little chart here to kind of practice the skill of going from one to the other and vice versa. So let's look at this first factor, 2x squared. A couple different ways you can think about it. One way is I can put a number into that variable. Whatever that number is going to be the solution or the root. And whatever, more in detail, whatever number makes that factor 0. So another thing you can do, another way you can solve that or find that, is to set that factor equal to 0. 2x squared equals 0. I divide by 2, so now I have x squared equals 0. I take the square root. Square root of 0 is 0, so I know that x equals 0 at that factor. Or if you think 2 is being multiplied by that variable, so what number multiplied with gives you 0. The only number that works there is 0. 2 times 0, if I was going to put it in for that x, would be 0. So that's why that solution has to be 0. Down here, these should look more familiar. X minus 3. And again, I could set it equal to 0, x minus 3, and solve. Get x by itself, I have to add 3. So x equals 3 here. But hopefully you can see the relationship between the root form x equals 3 and the factored form x minus 3. It's just the opposite sign. And again, another key factor that I noticed when I'm thinking about this and I'm trying to go from factored form to root form is factored forms have an operation like multiplication, or in this case it was x minus 3. Roots, or the root form, has an equal sign. And so that's actually when you find out what makes that factor 0. You'll have an equal sign there. So if you ever see x equals something, that's the root form, and you should be able to take it from the root form back to the factored form by flipping the sign or doing something like example 1 here. Now go ahead and try the third example. So pause the video and go ahead and try the third example, and be careful to check your multiplicities, because here I forgot my multiplicity. This power tells me that that 0 is happening twice, 0 with the multiplicity 2. And up here, x minus 3, there is no power, so I can assume that it's 1. So I can write 3 multiplicity 1. And so, pause the video and tell me what the solution is. X equals what with a multiplicity of what? Okay, hopefully at this point you pause the video. And so I'm going to answer that for you. X equals 4 with a multiplicity of 2. And you could just know to switch the sign or set it equal to 0 and solve. And I know that that power means that it's happening twice, so it's a multiplicity of 2. Now, we still need to go from root form to factored form as well. That's a very important skill as well. And so, x equals 3 with a multiplicity of 1. I know that it's a positive 3, so I can, in factored form, the relationship would have to be x minus 3. And then it's a multiplicity of 1, so I can put the power of 1 up there if need be, but I don't necessarily have to when it's 1. Moving on is 0. X equals 0 with a multiplicity of 2. This is a little trickier, but remember, same with the example up here, the only factor that has 0 as its root is when x is being multiplied with a number. 3 times that x would, and if that x was 0, would give me 0. And the multiplicity of 2 means that it's going to be x squared. So go ahead and try to tell me the factored form of this solution down here. X equals negative 2, multiplicity of 2. So go ahead and pause the video and work it out yourself and then check your answer with mine. If you don't get the same answer, please raise your hand so I can check your understanding. So at this point, the factored form of x equals negative 2 would be x plus 2. And because of that multiplicity of 2, it means that it's happening twice. So I need a power of 2. That is the relationship between the powers and the multiplicities. So if whenever there's a multiplicity of 2 in root form, I know that the power will have to match that multiplicity in factored form. Alright, to finish off this piece of notes, writing a polynomial in factored form, what I want it to go from is, let's say the solutions are x equals 2 with the multiplicity of 2, comma, negative 3 with the multiplicity of 1. Factored form is something like y equals then the factored of x, or the solution of 2, so x minus 2. And this multiplicity of 2 means there's a power of 2 times this solution, which is going to be x plus 3 with a multiplicity of 1. So this is a factored form, something like that I'm looking for. So just keep that in mind as well. I'm going to cover average rate of change in the next video. So let's go through an example of what this would look like. And so this is how I would want you to do a type of problem like this if you were given a graph of a polynomial and I was asking for the x-intercepts with multiplicity. So again, the x-intercepts are anywhere, and if I was looking at this picture and analyzing the information, I would know that x-intercepts are anywhere that it crosses the x-axis. I see 1, 2, 3, 4 times that it crosses the x-axis. So in this case then, I can write x equals, the first one is -3. Remember, if it crosses the x-axis, that is the solution. That gives me the x equals part. I have to take that from x equals to factor form down here. So x equals -3, and it's a multiplicity of 1, remember, because it's odd. Odd goes through the x-intercept. At -3, I'm sorry, odd goes through the x-axis. At -3, it's going through the x-axis. So, it's multiplicity of 1. And then comma. Next one is -1. And in this case, it's going through, again, the x-axis right there. So it's a multiplicity of 1. Comma, the next solution I see is x equals 2. In this case, it's still going through, so a multiplicity of 1. And then finally, my final solution is x equals 5 with a multiplicity of 1. Now, just for example, if this graph came down like this and bounced off there, and went back up in the same direction at this solution, then it would be, this would be x equals 5 with a multiplicity of 2, because again, even powers bounce, and 2 is an even number. That's just for examples. Please write that down and make note of it as well. So, to finish this off, this video off, to write it in factored form, I have to look at my x-intercepts that I just came up with. My first factor is going to be based off of this. And we just practiced this skill up here. And so if it's a solution of x equals -3 with a multiplicity of 1, I know that my factored form is going to be x plus 3. And that's raised to the power of 1. Multiplied by this solution in factored form, which is x plus 1 raised to the 1. Multiplied by this solution. It's a positive 2, so I know that it has to be x minus 2. Remember the relationship to sign switch from factored form to solution form and vice versa. And it's a power of 1. And then finally, x minus 5, the power of 1. And just to make note, if this was included, then it would be x minus 5 with the power of 2 because of that multiplicity of 2. So, at this point, you're ready to try on your own intercepts with multiplicity and factored form on this example that you can do on your own. So go ahead and try that. Pause the video, and then I'm going to work it out, and you can check your answer with mine. Again, if your answer doesn't look the same as my answer, please raise your hand so that we can talk about it. So hopefully at this point, you've paused the video. So let's look at the x-intercepts with multiplicity. I'm going to put x equals, and I see 1, 2, 3. So x equals -3 with a multiplicity of 1 because it goes through the x-axis. Remember again, here's the x-axis. It's going through the x-axis. And then the next one is -1. Still going through, multiplicity of 1. And then finally, 2 with a multiplicity of 1. And then in factored form, it'd be x plus 3 raised to the power of 1 times x plus 1 raised to the power of 1, and x minus 2 raised to the power of 1. And you are done. Again, if you didn't get that while you were working that on your own, please raise your hand and I will come check it.